Now we are going to see about the Unit 2 angle modulation. In the angle modulation, we cover phase and frequency modulation, narrowband and wideband FM, modulation index spectra, power relationships, transmission bandwidth, FM modulation, direct and indirect methods, and demodulation. In the angle modulation, we have frequency modulation, phase modulation. First we'll see about the phase modulation. It is a process by which changing the phase of the carrier signal in accordance with the instantaneous amplitude of the message signal. So here the amplitude and the frequency of the carrier signal is maintained constant. We have the modulating signal has been sent to a phase modulator, we get the phase modulated wave. If the modulating signal is sent to a differentiator, it has to be sent to the FM modulator with the carrier signal being added, we get the phase modulated wave. So the phase variation angle has been represented by phi of a carrier in proportion with the amplitude of the modulating signal. Let us consider the modulating signal Vm of t is equal to Vm into cos omega mt. The carrier signal is represented by Vc of t as Vc into cos omega ct, and the phase modulated signal Pm of t is given by Vc into cos theta I. So here after the phase modulation, the instantaneous phase value is given by omega ct plus kp into Vm of t, where kp is the constant of proportionality for phase modulation. Kp into Vm is being denoted as the modulation index for phase modulation. This is the waveform, modulating signal, carrier signal, and this is the phase modulated wave. In the frequency modulation, it is a process by which the frequency of the carrier signal is varied in accordance with the instantaneous amplitude of the modulating signal. We have the modulating signal, FM modulator, and the FM wave. The modulating signal is being sent to an integrator, and then it is sent to a phase modulator. We get the frequency modulated wave. So in the FM modulation, modulating signal is represented by Vm of t as Vm into cos omega mt, and the instantaneous velocity modulation omega I is given by omega c plus kf into Vm into t, where kf is a deviation sensitivity of frequency modulation. So del f is given by kf into Vm by 2 pi. And this is the value of instantaneous phase value of the frequency modulated wave. The modulation index mf is given by frequency deviation del f by fm. The final frequency modulated wave Vfm is given by Vc into cos omega ct plus mf into sin omega mt. This is the waveform, the carrier signal, modulating signal, and the frequency modulated signal. In the generation of FM, we have direct FM and indirect FM. In the direct FM, we have two types, FET reactance modulator, varactor diode modulator. In the indirect method, we have Armstrong method. The modulating signal is given to the integrator, to the narrowband phase modulator. Here it is controlled by the crystal control oscillator. We have the frequency multiplier. We get the frequency modulated signal. In the demodulation methods, we have two types, slope detector, phase difference discriminator. In the slope detector, it depends on the slope of the frequency response characteristics of curve of the frequency selective network. It can be a simple slope or it can be a balanced slope detector. In the phase difference discriminator, we have Foster-Seeley discriminator and a radio detector. Thank you.